Hey, it's Mr. Allred. We've been talking about graphing quadratics and we've got everything in place, so now we're going to do some examples to make you feel a lot better. Just to remind you what we're looking for, we're going to find y-intercepts, and there's always one. We'll find x-intercepts, and there could be more than one or there might not be any. As a note here, I say remember, but let me mention imaginary numbers are not intercepts. So eventually we'll get some examples where that is kind of clear. Find the vertex, which is the center of the graph, and there's always a vertex. And then we're going to graph them. Okay, so let's get to some examples here. So the first example we have here is f of x equals x squared minus x minus 2. So if we go through everything we want to learn about this, the y-intercept, remember that comes from letting x equal 0. So when I let x equal 0 in here, y equals negative 2. So that gives me the point 0, negative 2. So I'm going to come over here to my graph and put that on. So all I did was plug in 0 for the x positions up here and evaluate. Next, I'm going to find the x-intercepts. That's where I let f of x or y, however we want to look at it, be 0. So that's 0 equals x squared minus x minus 2. Some of these you can factor, some of them you cannot. I believe this one factors into x minus 2 times x plus 1. So the x-intercepts are, or the solutions are x equals 2, x equals negative 1. That tells me my intercept points are negative 1, 0, and 2, 0. So I'm going to plot those. Alright. So then I want the vertex. So remember, I get that as x equals negative b over 2a. And my b is negative 1, so that'll be negative 1 all over 2 times 1 for 2 times a. So I get 1/2. Uh-oh, I wasn't expecting that. But then I'm going to plug that into the function. So f of 1/2. So 1/2 squared minus 1/2 minus 2. So that's 1/4, and if I make common denominator, minus 5 halves. So 1/4 minus 10/4 looks like negative 9/4. Not what I was expecting. I knew the graph was nice. But this vertex turned out to be 1/2 negative 9/4. So I need to plot that over here. 1/2 negative 9/4 is a little bit less than negative 2. So not much further down. So over here and all the things I did, let me make sure you see my points. There's my x-intercept, 0, negative 2. Excuse me, that's my y-intercept. My x-intercept is negative 1, 0, 2, 0, and my vertex is 1/2 negative 9/4. So I'm going to connect those points coming out of the vertex toward the side where I have more options, and then mirror that going through the points on the other side. So I have my graph. Okay. The next one. f of x equals negative x squared minus 2x plus 3. So again, I'm going to start with my y-intercept. And that's not very hard. When x is 0, I get 3 back. I'm going to go ahead and plot that. Remember, we said there'll always be exactly one y-intercept. My x-intercept says I'm going to let y be 0. So I've got 0 equals negative x squared minus 2x plus 3. I need to factor that. Unfortunately, I don't do good with negatives. So let's see here. I'm going to pull a negative out. So I need to factor x squared plus 2x minus 3, which is x plus 3, x minus 1. So the solutions are x equals negative 3 and x equals 1. So the points are negative 3, 0, and 1, 0. Don't make too many assumptions. Make sure you get all your information before you decide that you might have some issues. So let's highlight the points we have, and they're plotted. So then we need a vertex. So remember that is negative b over 2a. So this will be negative negative 2 all over 2 times negative 1. So that gives me 2 on top, negative 2 on the bottom, so negative 1. That's my x part. So for my y, I need f of negative 1. So that'll be minus negative 1 squared minus 2 times negative 1 plus 3. So that's 5 minus 1, 4. So the point I get is negative 1, 4. For the vertex, we'll plot it, negative 1, 4. And remember, the vertex should be the highest point or the lowest point. It is definitely the highest point in this if you look at it. So if it's between points, that's scary, going up and down. But we can connect coming down, so we have an upside down U shape or parabola. Mine looks a little silly, but I could erase it, but let's just do our best. So the 3 characteristics we found allow us to graph it. Alright, here's another one. F of x equals x squared plus 4x plus 5. So y-intercept, y-intercept, we let x be 0, and if we plug in 0, we get 5 back. Then we want the x-intercept, where we let the function equal 0. So 0 equals x squared plus 4x plus 5. I don't believe that factors. You can try it, but I'm going to try quadratic formula to see what happens. X equals negative b. So that's negative 4 plus or minus b squared. That's 16. Minus 4ac, so that's minus 20. All over 2a, so that's 2. If I clean that up a little bit, negative 4 plus or minus the square root of negative 4 over 2. And I could keep cleaning that up. But this little guy under here, square root of negative 4, is imaginary, so there are no x-intercepts. Okay. So I forgot to plot my y-intercept, so let me go ahead and do that, 0, 5. Let's talk about the fact that we don't have any x-intercepts. So we have a U shape, and no x-intercepts means we can't cross the x-axis. We have a point above the x-axis, so there must not be any points below the x-axis. So that means it must be open up, and it must all be above the x-axis. So it's all in the first and second quadrant. But let's see here. Let's move ahead, find the vertex, and see if we can make an interpretation. Vertex, x equals negative b over 2a. We've kind of already found this, but that'll be negative 4 over 2, so negative 2. And then when we plug negative 2 into the function, let's see here. We get 4 minus 8 plus 5. So 4 plus 5 is 9, minus 8 is 1. So the vertex is the point negative 2, 1. I don't know why that disappeared. Let's plot it, negative 2, 1. So very important to realize that's the lowest point, since there's a point above it. So since the only thing you can do is connect it to the point to the right of it, the vertex here, we'll just do our best. And then we'll try to mirror it on the other side, just eyeballing it. Okay. So here we only had 2 points, but we also knew it wouldn't go down because it can't cross the x-axis with no x-intercepts. But when we couldn't factor it, we could go to quadratic formula. Now, just because we use quadratic formula doesn't mean it won't have x-intercepts. Let's see the next one. F of x equals x squared minus 2x minus 1. Okay, so in this example, once again, Plug in 0 for x, we get -1 for y. So we have the point 0, -1. Okay. X-intercepts. You may think this is going to factor, but it doesn't. So if I set x squared minus 2x minus 1 equal to 0, well, wait a minute, maybe, yeah, it doesn't factor, but let's see. Quadratic formula, so negative b would be a positive 2, plus or minus square root of b squared would be 4, minus 4ac will be plus 4, minus 4ac, yep, all over 2a, so that'll be all over 2. So a little bit of cleanup gives me 2 plus or minus the square root of 8 over 2. We have a square root, and it doesn't have a nice square root, but it is a real number. It's not the square root of -8 that we'd have to get rid of. It's the square root of 8. So let's clean that up a little bit. 8 can be broken down into, let's do it up here in case you forget. 8 is 2 times 4, which is 2 times 2. So there's a pair of 2's that we can bring to the outside and a single 2 that stays in. So when breaking down the square root of 8, it'll be 2 square roots of 2. So I've got 2 plus or minus 2 square roots of 2 over 2. That's a lot of 2's. I know you want to reduce it. This 2 on the bottom can only reduce with things outside of the square root. So that 2 can divide into the 2 2's outside the root up top. But be very careful, because it doesn't mean that term goes away. It means it reduces. So what you get out of that is 1 plus or minus 1 square root of 2. Okay. So that's two answers. That's 1 plus the square root of 2, 0, and 1 minus square root of 2, 0. Now I need a calculator, so let me pause. Alright, I picked up a calculator to get the approximation, so I put 1 plus the square root of 2 in the calculator and got about 2.41. 1 minus square root of 2, negative 0.41. So we'd like to keep the original values with the roots in them because they're correct. The other ones that we get from the calculator and round off are just an approximation, but we do need that approximation to help us figure out where we want to put this point. So we've got a point that is about 2.5 on the x-axis and a point that's about -1/2 on the x-axis. So far that looks like it may line up, but let's just kind of continue. So we've got our y-intercept and two x-intercepts, one in exact form, one set in exact form, and one set in approximated, but it's the same point. So the vertex, negative b over 2a, so that'll be 2 over 2, so 1. And then plugging 1 in, we get 1 minus 2 minus 1 would be -2. So my vertex is 1, -2. I'll plot that. 1, -2 down here. And you can now see that those x-intercepts make sense. So just because we got square roots and use the quadratic formula doesn't mean that we don't have x-intercepts. They don't have to be nice numbers. That number line has lots of stuff between whole numbers besides fractions, so it's okay. Now we don't want those imaginary, so we don't want negatives under the square root. So if you do go to the quadratic formula, be aware that some things will work, some things won't. But we'll connect these out of our vertex, so it's a parabola open up, and looking similar to this, going through all 4 points that we found. So that pinned it down without any real guesswork. All right, let's stop.